All right, it's time to get started. Welcome back to everybody. We have our homework due tomorrow, as always. And on Friday, we got our first test, which shall be questions up to number 10. I'm referring to the big list of topics. So there's going to be one question about each topic, number 1 through 10. Number 10 is the Shapley-Shubik power index, which we're talking about today. You should expect the questions on the test to be similar to the homework questions, although some of the homework problems I intend for you to use a calculator, just like add numbers together. The ones on the test will not have weird numbers to add together. But otherwise, you should expect the test questions to be similar to the ones from the homeworks. I realize we haven't had any homework question about the Shapley-Shubik yet. It's not on the assignment for this week, but I figure we might as well put it on the test. Remember the way the big checklist works is if you don't get it right, there's no penalty for not getting it right. So I might as well put more and more stuff on the test, right? That's just another opportunity for you to get it right. Anybody got questions about the test? I hope everybody has a good feeling of what to expect. But any thoughts? All right, I was going to. Today we're going to talk about the Shapley-Shubik, which is number 10 on the big list. My plan was to do some review type stuff tomorrow, so I hope that you will look over the topics and maybe bring some questions. If you have questions, particular ones that you want to go over more examples of, I would be happy to do any of that. So I'll try to prepare a little something, but hopefully you guys will have questions also. I hope that sounds all right. All right. Let's get on with the Shapley-Shubik then. That's what I want to talk about for today. At the end last time, I gave a little sort of brief introduction to this. The Shapley-Shubik power index. This is a specific method for measuring the power of each person in a weighted voting system. That's what we've been talking about lately, the weighted voting system. On the homework, it's mostly questions about veto, dictators, and dummies. And that's one way to talk about the various people in a weighted voting system. But the Shapley-Shubik is a much more specific way of measuring exactly who has the power. And the Shapley-Shubik, I'm going to write as SS. This measures power according to pivotal votes these are the technical terms, voting permutations. All right. So actually, we're going to talk about two different power indexes, the Shapley-Shubik, and the other one, unfortunately, just has another guy's name on it. The other one's called the Bonsoff, and you have to just remember which is which. But the Shapley-Shubik is the one about pivotal voters in voting permutation. So here's the very basic idea here. If I have a weighted scenario like that, let's say, here I have 5 different voters, and the quota is 6. And we're going to give names to them. I'm always just going to call them A, B, C, whatever. So let's say our 5 voters are A, B, C, D, and E. And we consider voting permutations. So a permutation, this is the fancy mathematical word for, is just a specific ordering of the voters. All right, ordering, we call that a permutation. And so, for example, here is a specific permutation. Of course, there are many ways you could put them in order, but that's one ordering. One possible ordering is that. That's called a voting permutation. You just put them in some order. And then, in this particular order, we can decide who is pivotal. what this means is you add the votes up as you go. So in this ordering has B first, and then A, then C, then D, then E. And I'm going to add those votes up as you go in that order and see whose vote is it in this particular ordering which actually makes it to 10. So the question about who is pivotal means you add the votes in that order and find who cast the actual vote which met the quota. All right? So we add the votes in that particular order and we find who cast the vote which met the quota. This is not hard to do, although you do have to kind of concentrate. Once you know what you're doing, you can sort of do all of this in your head, but I'm going to write out in extreme detail. B just by itself, that would be 3. I'm adding the numbers as you go. B by itself is just 3. What about B then A? This would be 3 plus, sorry, B is not 3, B is 2. I'm off to a bad start already. See that? B is 2, all right? B plus A, I'm trying to write in this order, one at a time. So first is just B, that's 2. Next is B and then A. That would be 2 and 3, which is 5. This is still not meeting the quota. Next would be B, then A, then C. So this is B plus A plus C. That's 6 actually, and this meets the quota. So in this particular ordering, the way I'm going to say this is in this order, B, A, C, D, E, C is pivotal. Because that's the one at which point we actually made it to the quota of 6, right? Before that, in this particular ordering, the B and the A were not good enough, but the C is the one that actually made it. And so C counts as pivotal. This is kind of like, shooting the winning basket in a basketball game or something like that, scoring the winning goal in a game. It's the one that actually makes it to the quota. Yes?
Wait, so on the test or like exam, will a question be like this?
No, this is a little part of how you figure out the Shapley-Shubik. So the question that you would expect to see is, I didn't get there yet. You basically have to do this little calculation. It's not much of a calculation, but you have to do this little thing several times, and that tells you the answer for the Shapley-Shubik. All right. Can we just do this one more time? How about who is pivotal in this order? C, E, B, A, D. All right. Sorry, I scrolled the numbers. But again, we are going to add these things up one at a time, sort of as you go. So and really, when you know what you're doing, you can do all of this in your head. But just because I'm writing out all the details, just C by itself is only 1. But if I have C and E, that is 1 and 1, which is 2. I hope everybody sees what I'm doing. I'm taking from the beginning, as you go, you add them up. So this is 1 first, and then 1 and 1 is 2. CEB would be 1 and 1 and 2, because B is 2. That's 4. Still not making it. Then CEBA, this would be 1 and 1 and 2 and 3. This is 7, which actually makes it to the quota. The quota is 6. You can go over, but we're trying to find who is the one that actually makes it hit the 6 or over. All right, and so in this case, A is pivotal. All right, in that particular permutation, A is the pivotal. All right, now, when you're doing this, sort of, once you know what's up, like I said, you can pretty much do this in your head. I hope that this is not such a big deal. If I, for example, were to write out the various numbers here, just copying the values of each of those 3. This is not so hard to do in your head, right? I can go 1 and 1 is 2. Another 2 is 4. That's still not good enough. 3 makes 7 though, and now that means A is the pivotal. So this you can, like I said, if you know what you're doing, You can do most of this in your head. Although it sounds complicated when I say it. It's like, tell your roommates to shut up so that you can concentrate. This is not so hard, I think. All right? Okay, so anyway, let's talk about how you actually, like, what is the Shapley-Shubik? It is, so here I'll write this as a little definition. This is the Shapley-Shubik power index. It is of a particular voter is the fraction. You can write this as a fraction, or sometimes people write them as percentages, but I'm just going to write them as fractions. The fraction of the time that this voter is pivotal among all permutations. All right. That's what the Shapley-Shubik is. The fraction of the time that this voter is pivotal among all permutations. So you have to consider all possible orderings of the voters, and then for each one, you see who is pivotal in that particular ordering. This will take you a few minutes to do, although it's really you are just doing this kind of a thing over and over again. So let's try a simple example. You will see what I mean. So this would be a typical question on the test or on our homework for next week. Find the Shapley-Shubik index for this here. 16, 12, 10, and 5. Right. And I will emphasize again, the whole thing that's interesting about this weighted voting is just by looking at the numbers, you may get the wrong impression about how things go. Like, to me, at a glance, by looking at the numbers, I feel like the 12 and 10 probably have similar amounts of power, and then the 5 is like significantly less. That's just because of how the numbers go. The Shapley-Shubik, though, can tell you actually the true story behind the numbers. Anyway, here's how I'm going to do this. I'm going to list all permutations. This is a bit annoying. I'm going to write them as perms. All right? They are A, B, and C in this case. There's only 3 of them. We got all, you have to consider all permutations. You can still see it, the words up there. You have to see which voter is pivotal among all the permutations. So I'm going to just make a little chart here. The perms here. All right? I have to just write down all possible ways that you can put these in some particular order. All right? So one ordering is A, then B, then C. I could also say A, C, then B. All right? And there are many other ways to do it. I find you have to make sure that you get all of them. So I find it helpful to have some kind of system. I write first of all the 2 that start with A, right? You can go ABC or you can go ACB. Those are the only ones that start with A. And now I'll write the 2 that start with B. I could go BAC or BCA, right? And then there's 2 that start with C, and that's it, right? CAB or CBA. So this is your chart. You have to list all possible permutations, and there should be 6 of them. If there's only 3 voters, there are 6 permutations. It doesn't matter what, if your rows of this chart are rearranged, that doesn't matter, but you gotta make sure you have all 6. Okay, and then I'm going to, just to help myself out here, I'm gonna have a column of just the weights in those particular orders. So A, B, C, I'm just gonna write those again, but writing the numbers instead of the letters. This would be 12, 10, 5. Because my intention eventually is to be adding these numbers up. Okay, ACB is 12, 5, and 10. I'm just writing the numbers instead of the letters this time. BAC would be 10, 12, 5. BCA would be 10, 5, 12. Nothing, not really doing much here, just writing stuff. 5, 10, 12. All right. This is all easy so far. I suppose it's easy to just mess it up by copying something wrong, but we're not thinking all that much yet. Here's the step where you have to actually think about it. In each of these rows, we have to find the pivotal. And this is the thing we were doing a moment ago. We are going to, so in each row from left to right, you add these numbers up and you see which is the number which actually makes it up to 16, all right? In the first case, 12 is not enough by itself, but 12 plus 10 is 22, which makes it to 16. So I'm gonna like circle this guy. The pivotal is B in that one, all right? It's the number which, as you're adding the numbers from left to right, the one which actually makes it go above 16, or meeting 16 exactly is okay too, all right? And you have to do that for each row. Again, this is not really difficult, it's just you have to concentrate a little bit. So in the next row, 12 and 5, 5 is the pivotal because 12 plus 5 is 17, and that exceeds the quota of 16. So pivotal in that one is C, the 5, right? And so on. Can anyone say what's the pivotal in the next one? The 10, the 12, or the 5? What do you say? A, the 12. Yeah, this one, it's the 12. That's because 10 by itself does not make it to 16, but 10 plus 12 is 22. That does make it to 16. So that's A. A. All right, how about the next one? You might find yourself wondering, is it always just the second one? It's not always the second one, and you can see right here. Here, the 10 is not enough. 10 and 5 is 15. Still not enough to make 16. You actually have to go all the way to the last one in this case. So this here is the pivotal. Sorry, that thing keeps popping up. I don't know how to get rid of it. That's A, right? Somebody else say, who's the pivotal in the next one? I think it's A, because 5 is not enough by itself, but 5 plus 12 makes 17, which is enough, so that's the 12 here. And then the last one, 5 and 10 and 12. I think, again, it's the 12. The 5 and the 10 makes 15, but that's not enough, so you got to go all the way to the 12. All right? And we see A is pivotal 4 times, B is pivotal 1 time, C is pivotal 1 time, and this is how you write the answer. So your final answer is A, 4 out of 6. You always write them as fractions. This is 4 times out of a total of 6 rows in the chart. A was the pivotal. B, 1 out of 6. And C, 1 out of 6. This is the Shapley-Shubik power index. All right? And this actually reveals the true power of each of these 3 people, right? Remember what I said at the beginning? I said just at a glance, looking at the numbers, it seems like A and B have similar power and C has less, right? But that's actually not true. You can see here, A has the most power by far. B and C are actually equal power. So here, the 12 actually has far more power than the 10, and the 10 and the 5 are actually equal in power. This is unexpected, in my opinion, just because at a glance, that's not what the numbers suggest, but that actually is the true situation underlying here. All right, this is the Shapley-Shubik. Let me just say, this also, sometimes people write these as percentages, so if you have a calculator, you can actually divide, you would do 4 divided by 6, and you get some decimal. This, I did this ahead of time. This is 66.6 repeating percent. This is 16.6, and this is also 16.6. So sometimes people prefer this way. Then you can see very clearly each one has a particular number that describes how much power they have in the system. All right. The B and the C have equal power. The A has a lot more. This is the Shapley-Shubik. So the fractions, just to make this clear, I think everybody can see how we did it, but just so that it's clear, the fractions every time looks like the number of times, let's say A is pivotal. That's the numerator of each fraction, the 4, the 1, and the 1, and then you divide by the total number of perms, which was 6 in this example. All right? And that's how you make each of these fractions for A, then B, then C. I think everybody knew that. All right, I got one more, and then I got one for you all to try to see how you like it. Let's try Same thing, let's find the Shapley-Shubik for this one. 12, 8, 7, and 1. All right? In this case, so I'm going to call them ABC like I always will. To me, just at a glance at the numbers, it looks to me like A and B have pretty much like similar power and C has less. Although we have to work it out to see if that's really true or not, but that's what it seems on the surface. So we're going to do the same thing. I would describe this as not all that hard, but you do have to take, it'll take you a few minutes to write down all the various steps. Anyway, I have to begin by writing all the permutations. Actually, this is exactly the same as the previous example. I have 2 permutations beginning with A, 2 beginning with B, and 2 beginning with C. BAC, BCA, CAB, and CBA. All right, these are all the perms. And then I'm going to write the weights in those particular orders. They would go 8, 7, 1. All right, the next one is 8, 1, 7. Then I would have 7, 8, 1, 7, 1, 8. And then 1, 7, 1, 8, 7, 1, 7, 8. I think I got those right. Those are the same reorderings, but just writing the numbers rather than the letters. And now the sort of important part, you have to decide for each one who is pivotal. And this we do by adding the numbers up one at a time from left to right and seeing at what point do we actually make it to 12 or above. I think in the first case it's the 7 which is pivotal. That is B, right? Because 8 by itself doesn't make it, but 8 plus 7 does make it. All right, in the next row, who's pivotal in the next one? I'm looking at 8, 1, 7. Oh, somebody said B, right? Yes, sorry, I thought you said 8, which is wrong. B is correct, yeah, the 7, right? 8 and the 1 is only 9, so you got to go to the 7. In the next row, 7 and 8, I think it's the 8, which is A. In the next row, 7 and 1 is only 8, so you got to go all the way to the end. It's the 8, which is A. I hope everybody is feeling it here. Here, 1 and 8, I got to go to 7. 7 is B, and in the very last row, it's the 8, because 1 and 7 is only 8. So that's A. All right? And so my final answer would be A gets 3 out of 6, B, 3 out of 6, C, 0 out of 6. This, you don't have to be a genius to write these as percentages, right? That's 50%. This is also 50%. And this is 0%. This is how much power each one has. So in this example, A and B have equal power, even though the number for A is bigger than the number for B. It doesn't actually matter. A and B have equal power. C has no power at all. This actually indicates that C is a dummy here. You will notice I never circled the 1. That means actually in this system, the 1 never matters. No matter what order they're voting in, the 1 never has any effect on anything. And that's the true nature of a dummy, right? It doesn't matter what the 1 does. It never influences the result. All right, any thoughts about this? I don't know if you are capable of having any feelings about the Shapley-Shubik. I think the Shapley-Shubik is kind of great. I don't feel great when I'm doing it. To be honest, I feel like it's kind of boring and you just have to like work out the same thing over and over again. I feel kind of like a tool when I'm doing it. But just the idea that you can take these numbers and come up with these other numbers, which tells you actually specifically what's really going on here in a way that the original numbers do not actually express what's really going on. These numbers, they do, and I think that's pretty great. All right, I got one for you all to try. Find the Shapley-Shubik for this 12, 7, 6, 5. See what you think. talk to your friends about it if you like. All right, I'm going to write my answers here. Everybody seems to be doing all right. This may take a few minutes depending on how good you are at adding in your head, which I really don't care at all. If you can do it fast. All right, these are the permutations and the weights in those particular orders. And then as we go down, we have to decide who is the pivotal in each of these. That is, I'm adding the numbers as I go and seeing which one makes it to 12. So in the first row, I believe it's the 6 because 7 and 6 is 13. So that's B. In the next row, I think it's the 5. 7 plus 5 is 12. That's C. It's okay if you add up to equal the number. You don't have to go over. You can go over if you want to. BAC, 6 and the 7 makes it to 13, so that's A. 6 and 5 and 7, that's A, because 6 and 5 is only 11. 5 and 7 makes 12, so that's A. And 5 and 6, again, it's only 11, so I got to go there. This is what I got. Anybody agree or disagree? As I was walking around, it seemed like most people agreed. All right, so my answer is A, 4 out of 6, B, 1 out of 6, C, 1 out of 6. All right. It's a little strange, again, looking at the numbers at the beginning. Who would have known, but it's true. The B and the C actually have the equal power here, but the 7 has much more. That's how it is. Yeah?
Sorry, I don't know if I'm thinking about this the wrong way, but does this mean that if thinking about it from video power and dummy situation, there wouldn't be a dummy here, and would A be video power?
It doesn't mean that, but it does mean that there's no dummy because nobody is 0.
Okay, but you can't figure out.
Yeah, you can't say about veto power.
Okay.
Actually, in this case, I think A and B both have veto power here, but not C. But yeah, that's a more difficult thing. All right, I got one more. We got 20 minutes on the clock. I don't know if we really need 20 minutes, just because this is all I wanted to get through today. I got one more. You may have noticed all the examples so far that we've done have involved only 3 voters. Let's try one with 4. So I'm going to just modify ever so slightly. 12 is the quota again. 7, 6, 5, but I'm going to just throw in another chump who gets only 1. What difference does that make? Well, we'll see. So this is 7, I'm going to call them ABCs again. But now I have 4 of them. What's the principal difference when there's 4 of them? The biggest and most obvious difference is there are many more permutations now, right? We had only 6 ways of writing different orderings before. Here we have, well, it's more than 6. Anyway, let's just see what happens. So my permutations, again, I'm going to try to do this in a sort of structured way, just so that I make sure that I get them all. These are the ones which start with A and then B. I could have also done A, B, and D, C, right? Those are the only ways you can do it, starting with A and then B. I could also start A and then C, that would, and then B, D, or A and then C and then D, B. All right, those are the only ways you could start with A, C. And then I could also start with A, D. So it could go A, D, B, C, or A, D, C, B. All right? And these are all the ones that start with A. There are 6 of them. We also need the ones which start with B. There's going to be 6 of those. There's going to be 6 that start with C and 6 that start with D. This is a real pain to do, and I would not ask you to do one like this on the test, just because I think it will take you a little too long to do all of them. Anyway, let's write all the ones that start with B. Okay, there's B, then A, C, D, or B, then A, the other way around, D, C, right? Or I could do B, then C, A, D, or B, C, D, A. Or I could do B followed by D, B, D, A, C, B, D, C, A. All right? Those are 6 more that start with B. Maybe I'll try and, can I fit them all sort of side by side here, just because I don't want to scroll everything? More perms over here. I can go C, A, B, D, C, A, D, B. Those are all the ones that start with C, A. And then I could go C, B, A, D, C, B, D, A. Or I could go C, D, A, B, C, D, B, A. Okay, those are all the ones that start with C. There should be 6 of them. And then finally, we have 6 different ones that start with D. They are D, A, B, C, D, A, C, B, D, B, A, C, D, B, C, A, D, C, A, B, D, C, B, A. There you go. Those are all the ones that start with D. All right. There are apparently 24 total permutations in this case. So at the end, when I write my fractions, the denominators will be 24 each time. All right, let's do the rest. So now I have the various weights. I'm going to see if we can, come on now. There we are. Okay, so the weights in particular orders. This one would be 7, 6, 5, 1. This one would be 7, 6, 1, 5. Remember when I said the other ones are kind of boring and tedious? This is like 4 times worse. This is the only time we're going to do one of these big ones. The next one, 7, 5, 6, 1. Got to get it right here. 7, 5, 1, 6. Okay, then I have 7, 1, 6, 5, 7, 1, 5, 6. I think I did that right. And then these ones start with B, so that's a 6 first. 7, 5, 1, or 6, 7, 1, 5, or 6, 5, 7, 1, 6, 5, 1, 7, 6, 1, 7, 5, 6, 1, 5, 7. If anybody walks by while I'm doing this, they'll be like, yeah, that's a real math class right there. He's just saying a bunch of nonsense numbers over and over again. This is not typically what mathematicians spend their time doing, but in real life, of course, you do all this on a computer. So this one is 5, 7, 6, 1, 5, 7, 1, 6, and then 5. B is 6. 5, 1, 7, 6, 5, 1, 6, 7. All right. Almost done. This one, these all begin with 1. So this is a 1, 7, 6, 5, or a 1, 7, 5, 6, or a 1, 6, 7, 5, 1, 6, 5, 7, 1. C is 5, 7, 6, 1, 5. All right. I think I got them all, and I hope I didn't mess it up. And now we find for each one the pivotal. Can we try all this together? How about this? I am going to just point. Let's go around the room. Each one will take one of these. It's time to start paying attention again if you've zoned out after all of this business. So could I start with you? In the beginning, the very first one here. Tell me who is pivotal in this one here. We are looking to get to 12.
6.
I believe it's the 6, yeah, which is B. All right, next.
B.
The 6 again, which is B. Great.
5, which is C.
5, which is C. All right.
I think it's, let's see, it has to add to 12.
Yep.
5.
It's the 5. Yep. That's C. You can pass if you want to.
Yeah.
Next.
B.
The B. Yeah, the 6. 7 and 1 is 8, so you got to go to 6. B.
C.
C, which is the 5. Great.
What was it, A?
I'm looking at you.
7A.
The A, yeah, 6 and 7. 7 is the one. A. Great.
Yeah, A.
Also A. All right. Can we go around the bend here?
A.
Yes. 6 and 5 is 11. A. Great. Next. D. Yeah. D is getting some play here. 6 and 5 is 11, and 1 is 12. So D enters the chat, as they say. A. Yeah, the 7 is A. Next.
C.
The 5. Yeah, which is C. Great. The 7 is A. Uh-huh. A again. Right.
B.
The 5.
Wait, A.
Yeah, I think it's A, the 7 here. All right. Everybody seems to be doing great. D, yeah, D. Holding it down again.
A.
A is next. Great. Avoiding eye contact.
Wait, B.
Yeah, I think it's this one here, right? 5 and 1 is 6, and another 6 is 12. Okay, great. B.
B.
B is next. Yeah, another 6. 6 is B. And the 5. Yeah, C. All right. A, the 7. Uh-huh.
C.
C. The 5. Great. A. The 7. Yeah. And the 6. Yeah, B. Excellent. Thank you all. That's great. We went all the way around the room exactly once. Although we skipped her. Okay. The work is done. We just have to sort of summarize the answers. So we just count each of them. We all did it together, didn't we? So the A's, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 A's. That's 10 out of 24 for A. B, we got 1, 2, 3, 4, 5, 6. 6 out of 24. I happen to know that's 25%. C, we got 1, 2, 3, 4, 5, 6 out of 24. And D. D was kind of the chump, right? 1, 2. 2 out of 24. This is my final answer. All right. Interestingly, remember before, oh no, it's not so interesting. Before we had B and C were the same amount of power. It's still B and C are the same amount of power. Adding in that chump didn't change a whole lot. We still have A is a lot, and then B and C are equal and a little bit less. All right, I think that'll do it. We got 10 more minutes on the clock. I would be happy to hang around and talk about questions on the homework if anybody has, if you've been working on it. Got any questions, feel free to stick around. Otherwise, I'll see you all tomorrow.